Welcome to the deep dive. Okay, so today we're taking a really fascinating look at the blueprint for successful AI-driven digital transformation. And we're focusing specifically on the global mining industry. I mean, this is an industry that quite literally underpins the entire global energy transition. We've got a stack of sources here, and they outline the roadmap. But it goes way beyond just the tech itself, right? We want to figure out what it really takes to scale AI value in this field.
That's exactly the mission. Defining the organizational readiness and the technical foundations needed for this huge strategic shift. And for you listening right now, the stakes are, they're enormous. We're talking about critical materials for clean energy tech, EVs, solar panels, wind infrastructure, and market demand for these mine materials. It's expected to increase, get this, fourfold by 2040.
Fourfold. Wow, that's intense pressure. And it really explains why AI is shifting from being maybe a nice to have to a necessity. Our sources show that immediate value proposition pretty clearly. Just employing AI in mineral exploration, study suggests companies could potentially save, 20 to 30% in both time and costs. That kind of efficiency gain is just vital when you need to ramp up production like that.
Absolutely. But here's the crucial insight, the one that every study really hammers home. Digital transformation, especially AI-driven transformation, it starts with people, not the tech. The most successful projects, they're the ones that tackle the organizational and cultural roadblocks first.
Right.
That focus on human readiness.
That's what we need to keep front and center as we dive into the specifics.
Okay, let's start there then, with the applications.
Yeah.
Where is AI actually making a difference across the mining value chain? Because it seems like it's truly end-to-end, covering upstream like prospectivity mapping, extraction, all the way to downstream like ore blending, processing, even side streams like the supply chain. Yeah, it touches everything. And what's really compelling are the specific high-impact use cases that industry experts are zeroing in on right now. Take resource sustaining, for instance. This is basically using technology to efficiently recover low-grade minerals or stuff that was previously overlooked, considered subeconomic.
Right.
It's finding value in what used to be waste, and that directly extends the operational life of existing mines.
So that resource sustaining piece, it's not just about saving money right now. It's also an immediate environmental win, right?
And helps long-term resource security.
Exactly. It hits multiple points. Then there's value optimization. This is super critical for complex deposits. A lot of modern mineral bodies, they host several valuable materials together. Think lithium with tin and tantalum, maybe, or gold mixed with other elements. These complex ores, they demand really innovative processing. AI refined techniques to make sure you maximize recovery of all the valuable minerals, not just the main one or the easiest one. And, as consumers, we're increasingly asking where these materials actually come from. So that brings us to traceability, I imagine.
Transparency and traceability are huge, yes. AI gives us tools for real-time monitoring. You can create a sort of digital thread that follows the material from the moment of blasting.
Right, through the process.
Right through to market delivery. We're talking potentially unique digital passports for metals, or maybe using trace element fingerprinting for, undeniable proof of origin, provenance tracking.
And mining, of course, involves significant environmental and safety risks. Tailings storage facilities, TSFs, they always come up as high-risk areas.
They do, and for good reason. TSF monitoring is a major focus. AI combined with remote sensing, sensor data, it's a powerful toolkit for near real-time monitoring of these huge structures. It's used not just to spot early signs of environmental risk like instability, but also to assess the materials in the tailings for potential economic recovery. That's waste valorization right there.
Interesting. Turning waste into value again. And then finally, for precision underground, you mentioned distributed acoustic sensing. That sounds pretty advanced.
It is technical, yeah, but the payoff is huge. Operational precision. That's what you get when you combine distributed acoustic sensing, or DAS, with AI. It lets you map blast-induced fractures and ore body geometry almost in real time. Gives you deeper insights into structural integrity, helps reduce ore loss because extraction is more precise, and improves safety overall. Operators get this adaptive, real-time picture of their underground environment.
Okay, so the potential is massive, clearly established. But now we circle back to that cold reality we mentioned at the start, the organizational roadblocks. You said the common fallacy is thinking AI is only about tech. Our research pointed to 5 core drivers of organizational readiness. Let's unpack those foundations, starting with driver 1, organization and culture.
Right, and here we are, back at the people, not tech idea. Success demands a culture that really values agile decision-making. and embraces the scientific method. Experimentation is absolutely key in AI. But the mining world, historically, it's cautious, often risk-averse.
That's the core tension, isn't it? So how do the sources suggest leaders bridge that gap between needing agility and having this deeply ingrained, maybe cautious culture?
Well, it requires pretty decisive action from the top. Leadership buy-in, top-down, is non-negotiable to drive the vision. Practically speaking, that means setting up a really clearly defined operating model, how AI decisions get made, how they're integrated, and crucially, embracing change management. That means continuous learning, providing upskilling opportunities so the existing workforce feels part of the change, not replaced by it. Adapt rather than resist.
Okay, so get the culture shifting, get the operating model clear. Then the sources stress this can't just be random acts of AI. It needs a defined business strategy. Driver two.
Precisely. The strategy has to define specific, measurable business outcomes tied directly to AI integration. The main goal here is prioritizing use cases. Not just adopting AI because it's trendy, but integrating it specifically to hit clear strategic goals. And you absolutely must have a clear investment plan, structured properly to effectively scale those chosen AI solutions across the business, not just funding endless pilot projects.
Right, moving beyond pilots to actual scale, which leads nicely into driver three, applied AI experience. This seems to be where the learning curve really starts to pay off in terms of speed.
Oh, absolutely. This is where you see huge cultural shifts happen, enabled by actually doing it. We heard this great anecdote. One company, their first in-house image analysis solution for identifying deposits, took them 6 months to build and deploy.
6 months, okay.
Yeah. But because they built a comprehensive data strategy and focused on rapid applied learning, they can now deliver a working, deployable solution in just 2 days.
Wait, 6 months down to 2 days?
2 days.
That's a staggering difference. That implies way more than just better code, right? It's a whole new way of working, accessing data, managing risk.
Exactly. It's the practical outcome of that cultural shift we talked about in Driver 1, proof it works. And generative AI. It's speeding up this learning curve even more, especially with all that legacy data mines have. Another company used Gen AI to sift through huge amounts of unstructured data, structuring extracts from almost 100 years of digitized internal exploration documents, old reports, maps.
A century of data basically unlocked.
Suddenly brought back to life, influencing how they rank prospects, de-risking new projects. It's incredible potential from dormant information.
Wow, okay, that naturally leads us to driver four, AI governance and cybersecurity. With all this data, all this value, governance has to be non-negotiable.
It absolutely is. It's not just about ticking compliance boxes. It's fundamental to trust. Governance means implementing clear processes, robust controls, and defining accountability structures for data privacy, security, and importantly, the ethical use of AI. It can't be an afterthought. It has to be baked into the strategy from day one to ensure compliance with all the industry regulations.
And the risk environment. It feels like it's only getting more intense. Mining organizations, handling critical materials for national infrastructure, they must be huge targets.
Oh, they are massive targets. The threats are sophisticated,
Mm-hmm.
often state-sponsored groups,
Yeah.
from places like Russia, North Korea, Iran, plus organized cybercriminals.
Yeah.
It's really an AI arms race now. Defenders use AI to enhance detection, automate responses, but attackers are using AI too for highly sophisticated targeting, finding vulnerabilities. Mining organizations absolutely need a threat-informed strategy. And strong partnerships, both with government and within the industry, are crucial for collective security.
Okay, so finally we get to the technology itself with driver five, technology and data strategy. What's the absolute bedrock requirement here?
The bedrock, across everything we've discussed, is quality data. Simple as that, but hard to achieve. It has to be accurate, it has to be consistent, it has to be properly formatted. If your input data is flawed, your AI outputs will be useless at best. Or worse, actively misleading. Beyond just data quality, organizations face these crucial architectural decisions. Where to host the data, cloud, edge, hybrid, ensuring the cloud infrastructure can actually scale, and making that strategic call. Do we buy existing off-the-shelf solutions or do we need to build custom ones?
That decision point, buy versus build, and the data quality, it leads perfectly into the necessary technical architecture. Especially for an industry like mining, often dealing with remote, isolated sites, huge data silos, what needs to change structurally to enable all this?
Yeah, the structure needs a fundamental shift toward open data platforms. The goal is to actively break down those silos, bridge the gap between where the data sits and where the applications need to use it. A prime example is the OSDU forum, the Open Subsurface Data Universe. It's working to unify subsurface data across oil, gas, and now mining, enabling much more seamless data access and integration.
And this trend of making data easier to access, it's happening even with complex government data sets too, right?
It is. Look at collaborations like NASA's Earth Copilot. They're leveraging cloud services, large language models to basically simplify how people access complex geospatial data. You can ask plain language questions like, show me areas in South America with high iron ore potential and low seismic activity.
Just ask it like that.
Yeah, and get relevant data insights back almost immediately. Imagine how powerful that is for exploration teams on the ground.
Definitely. So, given that mining sites are often remote, maybe with patchy or even non-existent network connectivity, this concept of an adaptive cloud approach seems really vital. How does that architecture actually unify these sprawling, often siloed systems into one coherent operations and data model?
Right, the adaptive cloud approach really hinges on three core capabilities needed to handle that complexity in these hybrid environments. First is central management capability. You need tools. Azure Arc is one example that can extend your standard management, governance, and security protocols across everything. Hybrid, multi-cloud, remote edge environments. Consistency is key.
Okay, so a single pane of glass for management, even across disparate locations. Once that's in place, what about actually creating that unified data foundation you mentioned?
That's the second capability, a unified data foundation. You need tech that can capture previously siloed edge data right there at the mine site using things like Azure IoT operations. And then feed that data into a central analytics platform, maybe something like Microsoft Fabric, up in the cloud. That creates the single source of truth needed for global insights. It lets the AI find efficiencies and boost productivity everywhere, using data from everywhere.
Got it. And the final piece for the actual operations on site, especially where connectivity is a real issue.
That requires the third capability, local disconnected operations. Simply put, applications have to be able to run locally at the remote site, even if the network goes down. This is done using specialized edge solutions like Azure Local, for instance, which specifically include features for disconnected operations. It means critical apps and services can be deployed and managed locally without needing that constant link back to the public cloud, directly tackling the limited network reality of remote mining.
This has been an incredibly thorough look covering both the strategic imperatives and the nuts and bolts technical requirements for AI transformation in mining. It seems very clear, though, there's no single magic bullet, no easy path to creating value. It really depends entirely on where an organization currently sits on its journey. Are they just exploring? Are they planning? Or are they already scaling?
Exactly. That individual organizational context is absolutely everything. But maybe let's leave our listener with the central challenge that emerged. The research is pretty clear. AI success seems to rely less on the specific technology stack, and tech is moving incredibly fast, and much more on getting the organization, the culture, the people, and the processes aligned. And those things are inherently slower to change. So the real provocative question, I think, is this. What practical steps can leaders take today to actually accelerate that cultural adoption, to help it keep pace with the rapidly evolving AI technology itself?
That really is the crux of it, isn't it? For almost every industry right now, not just mining. Whether you're working in mining or managing any large enterprise, maybe take these 5 foundational drivers we discussed, organization and culture, strategy, experience, governance, and data, and apply them to your own business context. Figure out where your biggest cultural hurdles are and what steps you need to prioritize next to bridge that gap between human readiness and technological possibility.